Alright folks, so we are back with a new series of video, and in this series what we will do is we will do a deep dive into the model context protocol, which is nothing but MCP, right? So this MCP is recently is taking all the hype and it's getting all the attentions due to its several features and how it can make your agentic systems much more production ready. So that we will talk about. So in this video what we will do is we will go through the very basic concepts of MCP, and then in the future videos what we'll try to do is we will try to do hands-on sessions where we will try to build MCP servers, then MCP clients, and we'll see how the MCP servers and client can interact between each other and how we can make our AI systems much more production ready, right? So without further delay, let's get started. So at first, the solitary LLM, right? So with the advent of ChatGPT, we have seen that the solitary LLMs are very useful, but they have a lot of limitations also, right? So they typically get a user prompt, and based on that prompt, with its given knowledge, based on the training data, it generates a response, right? So this solitary LLM is very limited in nature due to certain reasons. So one of the reason is that it has a huge dependency on the training data, right? So whatever the cutoff date that has been used to build the training data, and based on that the LLM will have the knowledge of the world, and beyond that it does not know what is happening in the real world, right? So that is where the dependency of training data is a major issue for LLM. Then we have no access to tools, right? So this solitary LLM does not have access to tools. So if you are building a chatbot system where you want to give the users the access to cancel their order, the fetch the order details, then reorder from that chatbot, that you cannot do using LLM because not have access to the APIs to your store mechanism or the purchase mechanism that you have in place, right? So that is where the solitary LLM will suffer. And also the solitary LLM does not have any autonomous behavior where it can make decisions or it can do the decision making. Like if a solitary LLM has multiple paths to go, then it cannot select which path I should select where I can get the maximum result or the most optimal result, right? With these limitations, what we moved into the next stage of this generative AI evaluation. Next step is that we got introduced to agents, right? Where the control flow was defined by LLMs, and we kind of augmented the LLM with certain tools or APIs or other mechanisms where this augmented LLM can go on in a loop and it can keep on taking the actions till it decides that now I have the final response which I can send to the user. So as I was mentioning, this the prompt will come to this LLM, and with this agentic architecture we will augment the LLM with different tools, memory, database, APIs. All those will be bind to the LLM, and the LLM will have this tools and the memory and the databases at its disposal, and with its own intelligence the LLM will keep on selecting this any of these tools or steps so that it can do the task that has been asked for, right? And once that it decides that now I have done all the tasks, then it can generate the response, right? So this is where the agent came into the picture and it tried to solve the issues that were present with the solitary LLM, right? So then with this agents also, with its design principle, we have seen that it has a few of the issues, right? So which we have recently discovered, and based on that this MCP came into the picture, right? So let's first talk about those issues. So as we keep on increasing or augmenting the LLM with different tools, there is a performance drop in terms of tool selection, right? So with a lot of options in terms of selecting the right tool, we have seen that if you increase a lot of number of tools, the LLM kind of gets confused, and there is a performance degradation in terms of right tool selection, right? So that is one of the issue. The other issue that we have in the agentic architecture is that the agentic architecture is very tightly coupled system, right? Where the agents are binded with the tool and these tools are binded very tightly, right? So if we are making any changes at the tool architecture, then a lot of developer effort is required in your agentic AI system to incorporate those changes because of this tightly coupled system that has been there in case of this agentic AI system, right? So then there is a challenge of system integration. So this integration of external systems like databases, APIs, etc. with your agentic AI system requires an in-depth knowledge of those systems, right? Whether that is a database or API or any of these tools, you need to have a very in-depth knowledge of those external tools. Without that, you won't be able to integrate those extra tools to your agentic AI system, right? So that is kind of a challenge if you are integrating those external tools or APIs or databases to your agentic AI system, right? So which requires a in-depth knowledge of those external tools, which can delay your agentic AI development phase, or it can take a lot of effort to build a agentic AI system with this integration of these external systems, right? So then we have a lack of communication layer. So your agent does not have a standardized communication layer that allows your agents to easily and universally connect it and utilize a wide range of external resources, right? So there is no such common protocol that is present, like the language that the agent can talk with the tools or the databases or the APIs. That is not a standardized format is currently present with this agentic AI system. So the communication layer is not there, right? So you might want to have different you might want to have a single communication layer through which your agents can talk to the tools or the databases or the APIs. So the lack of this communication layer is also a predominant issue in the agentic AI systems, right? So with these issues that we have discussed mainly with the agentic AI system, that is what we are trying to solve using the model context protocol, right? So yeah, if we have a top view of our model context protocol where we have a model, so that model gets the context using a protocol from these tools, databases and APIs. And this protocol is nothing but a core JSON RPC protocol through which the model kind of gets the context from an external tool. And this protocol is kind of a very universal in nature, so it does not depend on the tool or databases or API that we are using. It's a common protocol that has been introduced in this concept of MCP, and which allows it to connect to any of the external tools, databases or APIs to your model or the LLM, and based on that your LLM's context will be much more enriched with this external tools, data and APIs, right? So in short, the Anthropic kind of given us this definition of MCP, an open protocol that standardizes how application provides context to LLMs, right? So using this MCP, your LLM will get much more richer context with use of certain protocols, and that will kind of standardize the development of your AI systems, right? MCP will act as a USB which will provide a standardized way to connect your AI models to different data sources and tools, right? So that is what MCP is at the high level. Now slowly what we will do is we will look into the architecture of MCP, and we will try to see what are the different components that we have in our MCP architecture. One of the component is like a MCP host, where it's like a program like Claude Desktop or IDs or AI tools that want to access the data through MCP, right? So then your MCP host will also have a MCP client. So this client will maintain a one-to-one connection with the MCP servers, right? So this MCP servers are nothing but lightweight programs that expose specific capabilities through the standardized model context protocol, right? So you can see in this architecture that we have MCP server A, B, C. So your client or host can connect to multiple servers based on the MCP protocol. MCP server is nothing but it will expose specific capabilities through each of these specific servers, right? So then we have the concept of local data sources. So this local data sources are nothing but your computer's files, databases and services that MCP servers can securely access, right? So typically the servers are connected with the local data sources, which can be very specific to each of these servers, and that will can have access to your files, databases and services, right? So then we can also have remote services. So these remote services are nothing but these are external systems available over the internet, right? So that MCP server can connect to, right? So that typically this external or remote services are exposed through APIs, and based on that the MCP server can connect to a remote service through this web APIs. With this general architecture, with this nomenclatures, I hope you're now getting the different components that are present in the MCP, like the host, which also comprises of the client. Then we have a MCP server, which will give the context using either a local data sources or a remote service, and based on that the context will be provided to the host or the LLMs, and based on that much more richer responses will be generated, right? So then let's talk about the MCP servers. So this MCP servers, what we have discussed in the previous slide, will have mainly three components. So this MCP servers will have tools or resources or prompts. These are the elements the MCP server can be composed of. So if we talk about the tools, these tools are very model controlled, right? So you can see in the previous agentic architecture, we used to bind the tools to the LLM, and then the LLM can pick and choose these tools to deliver the task that has been given, right? So this MCP server kind of exposes a list of tools as an endpoint, and this application can pass this list to the LLM so that the LLM can decide which tools are needed for the given task, right? So those tools can be a retrieval or a search, or it can send a message, or it can do a DB update. So all these tools will be part of the MCP server, right? So then we have the concept of resources. Resources are nothing but different types of data that can be used by the application, and which can give much richer context for the LLM to generate different types of responses, right? So these resources are typically files, database records, or API responses, right? So the data is exposed to the application. So this is, again, as I mentioned, this is very application controlled. So this is neither a model controlled or a user controlled. This is very application controlled, right? So then we have the concept of prompts, which is user controlled, where the programmers of the server, right, so who are building the servers, they can expose specific prompts that can be injected to the application using LLMs, and can expose to the user of the given AI application, right? So these prompts can be like very specific prompts, like give me it can have a summarization prompt, right? So if your MCP server has access to a GitHub PR request, then you can have a prompt template which will go through that PR request. Then it will create a summary of that whole PR request and what are the tasks that has been done on that PR request, and based on that it can create a summary, right? So those type of predefined prompts can be exposed through the server. And also it can have other prompts, like where using that prompt you can generate the output as JSON, or it can have a prompt which is very specific to document question answer, right? So typically these are the MCP server that has been currently available in the market. So you can see some of the productivity tools are there, like servers related to Apple MCP, the Notion, the Slack. Then we have MCPs which are related to databases. Then we have a very specific MCP which are related to agent execution environments, and all these things are currently available as the server. So you can see also there are servers which are like Tavilai, which can be used for web search. So that all those facilities are kind of exposed as a server, and that can be integrated with your AI application using the server client architecture, right? Now slowly move into the concept of MCP clients. So this MCP clients are application or tools that integrate with the MCP servers to leverage external tools, data, and functionalities within an AI system, right? So typically these are nothing but desktop applications. The example of this desktop applications are like Cloud Desktop or Cursor or Windsurf Editor. So this can act as a MCP client, right? So then we have web applications, which can be browser based tools that connect to the MCP server. So some of the examples are like Chainlit, so that is nothing but a MCP client. Then we have the IDEs. Some of the IDEs can be like VS Code extension, VS Code GitHub Copilot, or Cursor, right? So that can act as a MCP client. Then we have the command line interfaces. So this command line interfaces will have a terminal based tools for integrating with the AI models and the MCP servers. Then we have frameworks, right? So these frameworks are nothing but language specific, like either that can be a TypeScript or a Java or a Python based frameworks. So typically we will see in the next few sessions, we will go through the LangChain MCP adapters. So those are the frameworks that can be exposed as a MCP client, right? So then we have like cloud platform integrations, which are the examples are like Amazon Bedrock agents. So those cloud platforms can also be used as MCP clients. So these are again the some of the typical top MCP clients that we have talked about, like Cursor, SourceGraph, Windsurf. So all these are nothing but an example of MCP clients. Now let's talk about a typical MCP workflow with a flow diagram. So we have our host, which is nothing but AI application. Then we have the MCP client, and also we have the MCP server. So at first there would be a communication between the host to the client, and that connection would be established. Then the client will send a handshake request to the MCP server, and that will be passed through the JSON RPC, and based on that the server will kind of give the response, and it will acknowledge that response, and then the client will ask the server that tell me what are the tools, resources and prompts that you have, give me the list, right? So that I can select the right choice of tools, resource or prompt to do my task, right? So once that request gets to the server, then the server will come up with the list of tools or the list of resources and the prompts. So for this example, I am just showing you that the server will come up with a tool list where it shows that it has a list of tools like get weather, get news or web search. So all these tools the servers has, and the server will expose those tool lists to the client, and then that information will be flown to the AI application once this client server handshake is done, right? So then the user will ask a question, or the user will fire a question. Like for this example, I'm giving a question like what is the weather of Kolkata currently. Once the user request is sent to the AI application, then the LLM that has been there, it will select the correct tool. So it will use the tool, and it will select the relevant tool for this question, and it will select get weather with the parameters, and then that information will be sent to the client, and client will be asked to do a tool call with the particular tool with the specific arguments, right? So here the get weather tool will be called with the argument that it needs to get the weather for Kolkata, right? So then that information will be sent to the server, and server will respond back with the weather data, and once the client receives that data, then client will deliver that weather data to the user, right? So this is where a typical MCP workflow looks like, and how this whole architecture has been designed. And you can see these are very loosely coupled systems where client and server are not tightly coupled. So any changes that we are doing at the server side, whether it's like a server has been built by a GitHub or a Google, they can do their own work. So that will be limited to the server side, and that will not affect to the AI applications, right? So the developer don't need to do a lot of code changes to integrate the changes that has happening at the server side, because we have a in between MCP layer which will facilitate those changes, right? And there is a common protocol that is going on between the client and server, which is nothing but JSON RPC, and based on that there is a common language that has been established between the client and the server, right? Now there are a few transport mechanisms which you can see in the screen, so that needs to be used whenever there is a communication between the server and client. So one of them is a STDIO transport, and the other one is a SSE transport. So in our code examples, which I will release in the next few videos, we will see like we will build a client server architecture in the STDIO format. We can build a SSE transport mechanism, which is typically for a remote server, which is a network based client server architecture. So that we will also see, and you can see like it has certain features like inbuilt authentication that is present in STDIO transport, but that is supported in case of SSE transport. So these are the few of the features that you should keep in mind whenever you are designing your system, whether your system is totally based on a local system or it needs a remote connection. If that is it requires a remote connection, then you should go for ISSC transport. So based on that, you can select which transport mechanism you need to use. Right. So if you talk about the benefits of MCP, so for the AI application developers, you can connect your AI app or your generative AI app to any MCP server with zero additional work. Right. So using that MCP, you can act that MCP as a kind of a USB-C device for your AI application, and that external server can be plugged into your MCP system, and based on that you will be connected to those external tools or servers. Right. Then for tool or API developers, like the person who are developing the server side, they will build it once and they will see the adoption everywhere. Right. So they will expose that in the MCP marketplace, and that will be adopted everywhere. Right. So then for the end users, you will get much more powerful and context rich AI application, because you have the lot of tools at its disposal, or the resources or the prompts, and based on that you can give much more richer context to the LLM. For the enterprises, there is a clear separation and between the client and server or the different teams. Overlap between the team is much more minimal, and based on that you can have a very simplified team architecture which can work independently, and lesser collaboration is required using this architecture. Right. So with this concepts, I will end this video. I hope you got an initial understanding of how the MCP works, and the next few videos we will try to do some hands-on part where you will get to know the concept in much more detailed manner. Right. So thank you. See you in the next video.